Hello, this is my presentation on the northern Beaufort Sea polar bears. Polar bears are divided into multiple subpopulations worldwide, and the one I chose to do my presentation on is northern Beaufort Bay. Polar bears are a keystone species in the Arctic as they regulate seal population and provide food to other organisms by leaving carcasses behind. They're an indicator of the health of an ecosystem. Because they sit at the top of the food chain, the level of contamination of pollutants in their blood can indicate the general health of an ecosystem. I chose northern Beaufort Bay because there is quite a bit of data for this region, but it's important to note that in 2013 and 2014, the boundary defining this region was changed. It went slightly westward. Since all of the data points taken for northern Beaufort Bay were revised at the latest in 2011, not all of the data stands to be accurate to the new defined borders. The reason that this border was shifted west was to increase the distinction between the populations of southern Beaufort Bay and northern Beaufort Bay. The data that most of this presentation is based on is from Ian Stirling's Polar Bear Population Status in the Northern Beaufort Sea, which has data from 1971 until 2006. It's also important to note that there are discrepancies between how different organizations interpret the data from Ian Stirling, who is the main source for information about population of the polar bears of northern Beaufort Bay. For example, Polar Bears International on the left, their population map deems the short trend of northern Beaufort population as of 2023 of polar bears as data deficient, so it cannot label them as stable or otherwise. However, the Government of Canada on the right, their population map deems the recent population, this map is from 2022, as likely stable. I'd also like to talk about the northern Beaufort Bay itself. The northern Beaufort Bay borders the Arctic Ocean and receives consistent cold water from the Beaufort Gyre. Most of the year, it has open water in the Shorelite and Polynia systems. Pack ice is an area of ice that is not attached to land and is composed of smaller fragments and is usually mobile, and a shore lead is a waterway between pack ice and the shore. A polynia is a stretch of unfrozen water amidst ice sheet, like pack ice. Polynias often support algae and lots of marine life, so this is where you would find many animals like seals. In terms of year-round weather, most of the year has open water, and the freezing of the shore lead usually happens between mid-October and mid-November and lasts until late May or late June. The area of the northern Beaufort Bay subpopulation is around 940,000 kilometers squared. The population measured in 2006 was estimated to be 767, but because this data has inconsistencies, the estimates for how many bears are actually in the area are higher, around 1,200. The crew density is estimated to be around 1.2 bears for 1,000 kilometers squared, whilst the ecological density, mostly due to the fact that a lot of this land is just open water, is much higher at 4.7 bears per 1,000 kilometers squared. Reasons for inconsistencies in the data include the fact that the latest assessments were around 2006. Less than half of the range of the northern Beaufort Bay area was able to be analyzed, and methodology for estimating population sizes has changed. The polar bears of northern Beaufort Bay are dispersed individually with a large range that focuses on sea ice, since they are dependent on it for hunting seals. However, mother polar bears stay with their cubs for about 2.5 years and remain more inland, whilst individual polar bears go out to ice and shore. In the summer, the bears tend to move northwards where it's colder because there is more ice. The sampling method used and cited by Ian Stirling's report was non-selective mark recapture. They attempted to capture all the encountered bears. These bears were anesthetized with immobilizing drugs, which were fired from projectile syringes on a helicopter. The captured bears were given ear tags, tattoos on both sides of the inner surface of their upper lips with a unique identification number, so that if they were recaptured, they could be identified as already counted within population estimates. The length of their body was taken from the tip of their nose to the tip of their tail, their axillary girth, the age of accompanying bears and how many there were, their fat condition, and a tooth was also collected to determine their age. Ian Stirling's analysis also includes data taken by radiotelemetry, which are radio waves to determine locations of animals. Sensors are used to collect data, such as temperature, heart rate, and etc., which are transferred to a receiver. Bears that were captured were fitted with radio transmission collars, and these collars were assumed to function for 2 years after they were given to the bear. The bears that were captured by radiotelemetry were counted as equivalent to physical captures. Mortality rates for the bears included harvested ones from hunting. Survival estimates included that the bear remained in the study area, so if it left, it may not have been accounted for. Estimates were averaged to determine survival mortality rates and recapture probabilities. The population size that Ian Stirling determined was estimated by AIC weighted model averages, which determine how much information is lost to error and determines the quality of the model. The models were also fit for temporal variation, which is the fluctuation of density of organisms over time, as well as individual constraints. The study mentions that, to quote, "Our estimates appear to be consistently lower than those estimated in several other polar bear subpopulations. We have insufficient data to explain this, but we hypothesize that part of the difference may lie in the inability of researchers to consistently sample the entire NB region. This includes limitations with radiotelemetry and helicopter sampling, as well as capture-recapture's inability to determine a difference between dead animals and ones that are unavailable to capture, such as animals who have moved outside of a specific area. Also, budgeting limitations prevented sampling in one area of northern Beaufort Sea near Prince Patrick Island, despite some data showing that bears were moving to that area. Biotic potential and fecundity. There is a 33.3% chance per female to have a cub each year, since they theoretically breed every 3 years or so, and cubs stay with their mothers for about 2.5 years. The average number of cubs born is 1.6. Over a period of 3 years, this would be 0.53 cubs per year, but the actual rate of reproduction is about 0.4 cubs per year. Bears in general have quite low rates of fecundity compared to other animals, but this is still lower than the biotic potential. The Alley effect does have an impact on the reproductive rates of polar bears. Due to occasionally unsuccessful fertilization and the great distance between polar bears' territories, it's estimated that there should be around 2 to 3 males for each female to ensure that mating actually occurs. A skewed sex ratio means less reproduction will happen, and fecundity will lower. A decrease in population of polar bears also means that each one has more difficulty finding a mate. Another problem is the fact that chemical contamination, which is very present in polar bears in the Arctic, can result in male infertility, which would render otherwise successful mating unsuccessful. Here is a graph of the population of polar bears in the northern Beaufort Sea from 1986 to 2006. There are only data points for 8 of these years, meaning that we don't get to see anything that happens for a 10-year period from 1990 to 2000. This means that trends within growth are more difficult to identify, but it does seem quite consistent and also similar to logistic growth, as in 1987 to 1988, as well as 2005 to 2006, the population estimate appears to fall drastically after reaching approximately 1,200 bears. Using data points from this graph to calculate growth rates, From 1986 to 2006, we start with 912 bears and end with 767, which indicates a negative 12% growth, so a decline. However, the data from 2005, in which the population estimate is 1,345, would have had a growth of 45% of the population as compared to 1986. This shows that the real data is probably somewhere in between negative 12 and 45, because there's a huge difference between them over a very short period of time. The discrepancy between these data points is again most likely caused by limitations in the capture and recapture technology that was used. The carrying capacity for the northern Beaufort Bay has been estimated to be approximately 1,700, but the few existing population estimates are consistently below this. The primary limiting factor is suitable sea ice habitat in which seals can be hunted. Polar bears rely on the sea ice to feed themselves. However, it's important to note that the northern Beaufort Bay has had more stable ice conditions over time and more stable access to food and habitat for bears than, for example, southern Beaufort, which is the neighboring region. Density-dependent stressors include competition for food and disease that is spread among polar bears. Because of their dependency on sea ice to hunt their prey all year round, southern Beaufort Bays have begun to migrate northwards within their defined territory to find ice. If many bears all move towards the same region, their density within those regions will increase, and so will competition. Because of the amount of sea ice declining each year, bear densities may get more crowded, which will lead to more competition, less food, and higher mortality rates. Independent stressors include climate change and human activity. Part of human activity includes hunting, which is a traditional practice carried out by the Inuit people in the region. Population reports have also estimated an acceptable quota for hunting, which is around 50 bears, but consistently less than the quota of hunting has been satisfied each year. So around 40 are usually hunted, which means that this is not a particularly harmful activity. One thing that is particularly harmful that humans do, however, is cause the bioaccumulation of pollutants as well as the loss of habitat. The bioaccumulation of pollutants is caused by fisheries, ocean dumping, and toxic chemicals that build up over time in other animals and travel to the Arctic. Loss of habitat is mainly caused by global warming, which is a product of climate change, which is determined to be human-caused. Symbiosis is a relationship between two or more species in which organisms depend on another species to sustain life. One example of a symbiotic relationship with polar bears is their relationship with Arctic foxes. Polar bears, upon eating seals, leave carcasses with plenty of meat still on them. The foxes feed on the wastes of polar bear meals. They also tend to follow the movements of polar bears because they know that food will follow. Occasionally, in scarce conditions, polar bears will hunt Arctic foxes for food. The impact of humans on these polar bear populations is almost exclusively negative. Traditional hunting, again, isn't a very notable impact, but climate change and global warming are, as this causes loss of sea ice, loss of habitat, and more difficulty for the polar bears to find food, as well as causing damage to marine ecosystems in general, which rely on the types of temperatures that have been stable in these regions. Humans are also the reason for the abundance of chemical pollution in the Arctic. Some pollution isn't even directly brought into the Arctic, but travels there through the grasshopper effect, which is when small particles of a pollutant in a hot area rise in the air because hot air rises, attach to particles, and once in a cooler air, fall back down. They continue these bursts until reaching somewhere cool enough where they will not become airborne again, which is the Arctic. Fisheries contribute to a lot of plastic waste in the Arctic, and ocean dumping of garbage and chemical products. The dumping of forever chemicals causes buildups within the ecosystem. There are many persistent organic pollutants, such as agricultural chemicals, which attach to animal fats and resist breaking down. Polychlorinated biphenyls, PCBs, were formerly used in electrical equipment. They are found concentrated in polar bear fat and disrupt endocrine and immune systems despite having been removed from use. PFAs, which are forever chemicals used in non-stick coatings, repellents, bind to proteins and accumulate in liver and blood. Heavy metals such as mercury accumulate through the food chain, as well as other forever chemicals. Because some of these pollutants are lipophilic and bond to fat, they are eaten by animals higher up on the food chain and stay within that predator system. Since polar bears are very high up on the food chain, they are susceptible to bioaccumulation and have been found to have high concentrations of pollutants inside their blood. There have also been cases where polar bear stomachs have been opened and reported to have plastic residues inside. Some animals also risk dangers such as entanglement in a fishing net, for example. PCBs, which have been found in polar bears, have been linked in studies on rats to infertility, and this infertility applies to polar bears as well. This increases the chances of lowering reproductive rates, which is not good for maintaining a steady population size or to increase it. It has been predicted that for the next 3 generations of polar bears, so the next 35 years, there will be a steady decline in the population. Canadian polar bears also account for 60% of the global population, so doing something in Canada to maintain or grow these populations would be benefit to polar bears globally. The main goal of the management plan is to increase the population of polar bears as well as their health itself. Although there are problems like declining sea ice and warming waters, one problem which is of greater effect to northern Beaufort Bay polar bears than warming is the amount of chemical pollutants inside of their bodies and their ecosystem. PCBs have already been removed from use, but there are other pollutants and chemicals that are added to the ocean systems constantly. For example, fisheries contributing to plastic waste, garbage being added to the ocean. These all introduce bad things to the ecosystem, which can have a detrimental effect on the health of polar bears. The thing that would reduce the most the amount of new pollutants being added are policy changes. This would mean tighter regulations on fishing equipment and industries which dump waste into the ocean and waterways. It would mean more regulation of forever chemicals for chemical companies themselves to try and produce things that are less harmful to the environment. This intervention would not just help polar bears, it would help all of the organisms within the Arctic area and the marine area, and also things unrelated to the Arctic, as hopefully policy would extend there as well. The difference made by policy changes, so the success of the management plan, could be measured by monitoring the population of polar bears and seeing whether they maintain their population or if there is a slight increase. It would also mean checking the general physiological health of the polar bears as well as their fertility. If we see that right now fertility is being negatively impacted and some male polar bears are unable to reproduce, and then we check back in 10 years and see that fertility rates have greatly improved and reproduction has gone up, we know that the reduction of chemical pollutants has helped. Samples of water, soil, and snow can also be taken and measured for contaminants over time to see if there is an increase, if it stays the same, or if there's hopefully a reduction in concentration over time. As seen in Ian Sterling's analysis of polar bear population, there is a difficulty to accurately gauge how many polar bears are within this huge 1 million kilometers squared area. Population estimates would likely have to be paired with other measures of pollutants in the ecosystem to see if there is a correlation between the amount of pollutants and the rough estimate of population size. Ethically, this plan will definitely cost industries money since they will have to adopt new mechanisms of waste disposal or different chemicals which are less harmful, or put more effort and time into a safer waste disposal. They will lose money. The economy will be slightly less prosperous. However, the entire ecosystem will benefit from having less pollutants within it. Polar bears aren't the only species that are affected by this, especially when it's a case of bioaccumulation. Bioaccumulation means that every organism that the polar bear is consuming in the food chain probably has levels of this contaminant in it, which build up as different organisms eat the smaller organisms. The pollutants that are found in polar bears and are harmful to polar bears are likely harmful to all the other organisms as well. A reduction of pollutants means that biodiversity will be supported and thrive. A biodiverse climate is better for the world in general because biodiverse ecosystems are more self-sustaining. Since there are also people who live in the Arctic, the ethical benefit to humankind of reducing pollutants means that the people who live in the Arctic will be also less affected by these pollutants. Many of the Inuit people who do hunt for some food will be consuming the fats of the animals, and polar bear fats, for example, due to the lipophilic nature of many contaminants, are polluted. As these are accumulating chemicals, they will be found inside of the people who eat them as well. So, it is also a benefit to humankind to create policies which reduce chemical waste. To summarize, polar bears are a keystone species, are necessary to the ecosystem that they live in, as they regulate seal populations, provide food for other organisms. They are a fragile species with a heavy dependence on their habitat, which is being harmed negatively by climate change and global warming. Other human activities which, paired along with habitat loss, are detriment to their population and their reproductive rates, is chemical pollution. Since many of these are forever chemicals and build up, they cannot really be removed from the ecosystem, and instead, measures must be in place to make sure that no more are added in. This way, we give polar bear populations a chance to recover, which will support ecosystems and biodiversity.